Hello everyone, I welcome you to my physics class, Standard 8, Chapter 2, which is measurement of density. In the previous class, we discussed about measurement of density of irregular solid using Eureka can. Today, I am going to discuss about the measurement of density of irregular solid using measuring cylinder. So to do so, to determine the density of an irregular solid using measuring cylinder, we need our requirements: a physical balance, a measuring cylinder, a piece of thread, water, and the irregular shaped solid, let it be a stone, whose density is to be determined. First of all, determine the mass of the solid object using physical balance. Let the mass of the object be m gram. Mass of the object is equal to m gram. Let it be. Second, take the measuring cylinder. Now take a measuring cylinder and fill the measuring cylinder up half of its capacity with water. Now note down the reading of the level of water, and it could be the initial volume of water and could be denoted as B1. Initial volume of water, and it could be denoted as B1 centimeter cube. Then take a thread and tie the solid object with the thread and insert the irregular solid object into the measuring cylinder slowly in such a manner that it would not touches the walls and bottom of the container or bottom of the measuring cylinder. Now the level of water rises gradually and it reaches to a certain extent. Now note down the increased level of water and let it be the final volume of water. We could say it as the final volume of water and could be denoted as B2, and let it be B2 centimeter cube. Now volume of irregular solid is equal to B is equal to final volume minus initial volume. Final volume is V2 centimeter cube minus V, and initial volume is V1 centimeter cube, and let it be V centimeter cube. Let the volume of irregular object or irregular solid object be V centimeter cube. Let us denote the volume of irregular solid as V and its final volume is V centimeter cube. Now density of the irregular solid, density of irregular solid is equal to mass by volume. Mass of the solid is m gram by volume is V centimeter cube, that is m by V gram per centimeter cube. This gives the density of the irregular solid object. Now let us solve some numerical problems. When a rock of the mass 75 gram is dipped in water, the level of water rises to 75 centimeter cube from 150 centimeter cube. Calculate the density of the rock. Given that mass of the rock is 75 gram and volume of this rock is 175 minus 150, that is 25 centimeter cube. Density is equal to mass by volume, that is 75 gram by 25 centimeter cube, the 3 gram per centimeter cube. Measurement of density of liquids. Liquids can also have density, so let us see how to measure the density of liquid. For to do so, we need measuring cylinder, liquid whose density is to be measured, and a beam balance. First, measure the mass of the empty cylinder using the beam balance, and let the mass of empty cylinder be mass of empty cylinder is equal to m1 gram. Now for 100 ml of liquid in the measuring cylinder, now again measure the mass of the measuring cylinder along with the liquid, and mass of cylinder with water is equal to m2 gram. Now calculate the mass of the liquid. Therefore mass of liquid is equal to mass of liquid with water, mass of cylinder with water minus mass of empty cylinder, that is m2 minus m1 gram. Now substitute the value obtained in the step 1. Therefore, and we put 100 ml of liquid, means the volume of liquid is 100 ml. So density is equal to density of liquid is equal to mass by volume, that is mass of the liquid is m2 minus m1 gram by volume of liquid is V gram. Volume of liquid is V centimeter cube. That gives the density of the liquid. Now we discuss about relative density. Relative density of a substance is the ratio of its density to the density of other substance. When a solid object is dropped in a liquid, it either sinks in the liquid or floats on the surface of the liquid. Whether the solid will float on the surface of liquid or will sink in depends upon the relative density of the solid with respect to that liquid. If the liquid in which the substance is immersed is water and the temperature of water is 4 degrees Celsius, then the relative density of the substance with respect to water will be the ratio between the density of the substance and the density of water at 4 degrees Celsius. Now sinking and floating of the object depends upon the relative density. If the solid sinks in the liquid, then the density of solid is less than the density of liquid. If this solid floats on the surface of the liquid, then the density of solid is less than the density of liquid. Hydrometer is an instrument which is used to measure the relative density of liquids. So relative density, the formula of relative density is density of substance by density of water at 4 degrees Celsius. Here the density of water at 4 degrees Celsius is taken because the density of water at 4 degrees Celsius is highest. That is why the temperature 4 degrees Celsius is mentioned. Relative density has no unit because it is a ratio of two similar quantities. It is a ratio of two densities, so it has no unit. It is a unitless physical quantity. Now, if the relative density of a solid or liquid is more than 1, then the substance will sink in water because the density of water at 4 degrees Celsius is 1. So if the relative density of solid or liquid is more than 1, then the substance will sink in the water. If the relative density of a solid or liquid is less than 1, then the substance will float on water. Why this happens? Look at this table, you can understand it better. Substance ice, density of ice is 0.92, density of water is 1 gram per centimeter cube. Iron is 7.89, gold is 19.3, aluminum is 2.7 gram per centimeter cube, cooking oil is 0.92. You see, the density of ice is less than the density of water. This is why ice, which is the solid state of water, floats on the surface of water. But if you drop a piece of gold in the liquid, in water, it sinks because the density of gold is 9.3 gram per centimeter cube, which is much more than the density of water. This is why it sinks. Some numerical problems. The volume of 100 gram of substance is 8 centimeter cube. The density of water is 1 gram per centimeter cube. What will the substance float or sink? Density of substance, we know mass by volume. So 100 gram by 80 centimeter cube, 1. And the measurement of density of irregular solids using Eureka can and measuring cylinder. And with this, your chapter 2 completes. Thank you very much.